Algebra 1, Lesson 91. We are combining a couple different ideas here that we've looked at in the past, both absolute value and inequalities, so that we can solve absolute value inequalities. So first, when we're looking at this, absolute value inequality has at least one absolute value expression, which means that, so say we think about an inequality like x is less than 6. That means that we have an infinite number of solutions when x is less than 6. So all of those that are under 6. Okay? Now, if we were to change this to be an absolute value equation, okay, so this is our normal inequality, maybe we change it and we say, well, what did we learn when we had absolute value of x equals 6? Well, when we had that, we said x has a couple different possibilities. X could be 6 and x could be negative 6, always taking what's inside of the absolute value and taking 6 and its opposite. Now, when we transition to have absolute value inequalities, so say we have the absolute value of x is less than 6, we can think about this and say, well, any number, we have a couple different answers here. We have any number that is less than 6 and any number more than negative 6. Okay, so thinking about this, if we were to use this kind of like our absolute value equations, we would say x needs to be less than 6, so using what's inside of the absolute value and the number, okay, with the same inequality sign, and then we can flip it and we can have x negative 6 and we flip the inequality sign, so we use the opposites. Which means that if we're thinking about compound inequalities, we're actually thinking about our situations that are conjoined, that come together, that start and end and actually connect in the middle. Still an infinite number of possibilities here, but any of these numbers in between would work, and they do have to satisfy both conditions. If we change the problem just slightly and use a greater than sign instead, let's see what happens. And we're going to use the same method of saying x needs to be greater than 6, x needs to be less than negative 6. And if we were to put these on a number line, we would see that the first inequality would be going this way, second inequality would be going this way. So we actually don't have an and situation, we have an or situation. X can be greater than 6 or x can be less than 6. We're looking at those absolute values that are going to give us bigger numbers than 6. So it would make sense that they would have to be both big numbers above 6 and small numbers below negative 6. That would work for these absolute value inequalities. So let's look at a couple more examples. The more we do, the clearer it will become. So absolute value of x is less than 4. That means, well, we have a less than symbol, meaning we're actually going to have a compound inequality where it comes together, an and situation. So I have x is less than 4 and x is greater than negative 4. We could combine these to one absolute or one inequality to say negative 4 is less than x is less than 4, just like we've done in the past, so that we can put it on our number line like this and have open dots on each of these combined in the middle. That's our less than. When you have a greater than, we can say x is greater than 7 or x is less than negative 7. Okay, we flip everything. So we have on the number line open dots, but in this case they're not combined, they are going away from each other, because if we were to choose something, let's say down here at negative 9 and plug it in, the absolute value of negative 9 is greater than 7. So we need all of those possibilities. Now, what if we don't have the absolute value by itself on a side? Well, we need to get it by itself on a side. So we can't touch anything that's inside of the absolute value, but anything outside we can deal with. Like in this case, I'm going to subtract 7.4 to find that the absolute value of x is less than or equal to 2.4. Meaning that x can be less than or equal to 2.4, and because it's a less than sign, we can have x is greater than or equal to negative 2.4. meaning this is one that combines in the middle. All right, and we have closed dots in this case connecting. Okay, so we need to get that absolute value by itself. All right, so same with this one, we're going to add 2.2 to each, and this one will be an and situation, so it combines in the middle. Now, very similarly, we can add and subtract things, but we can also multiply and divide to get our absolute value alone. So in this case, I'm going to multiply each side by 8 to get absolute value of x is greater than 8. This is an or situation since we want those bigger numbers to get greater than 8. So I'd say x needs to be greater than 8, or x needs to be less than negative 8. So I have 8, negative 8. We're going to have open dots going away from each other. And similarly here, I'm going to divide by 3 on each side and get absolute value of x is less than negative 3. Now, when I see this, just like if I were to say absolute value of x is equal to negative 3, that is not possible. We can't take a number and get, we can't take a number with the absolute value and get a negative number. So in this case, if I want a number that's less than negative 3, I could try some possibilities like the absolute value of 2 is less than negative 3. That doesn't work. Absolute value of negative 5, is that less than negative 3? Nope, it's not. This one is not possible. Okay, there is no solution. Now, I want you to be careful because if you see an absolute value with an inequality and a negative number, it doesn't mean that it's automatically no solution. If I have, let's say the absolute value of x is greater than negative 3. Well, let's plug in some values there. What if I said absolute value of negative 1? Is that greater than negative 3? Yes. Or absolute value of 0, is that greater than negative 3? Yes. Actually, all real numbers will work for this. So be careful. If it's a less than symbol with a negative number, we have no solutions that will work. If we have the absolute value and a greater than sign with that negative, then all numbers will work because everything will give us a positive number that will be greater than that negative. Okay, so be careful. Now, last little bit of this. What if we have the absolute value and there's extra things inside of the absolute value? Well, just like if we were to take the absolute value of x plus 1 is equal to 3, we would have to split this up into two different equations. X plus 1 is equal to 3, and x plus 1 is equal to negative 3. And we would solve those for x. We're going to do something very similar here, and just like we split it up in the last time, we would say x plus 1 is less than 3. Since it's a less than, we have an and, so x plus 1 is greater than negative 3. We use that opposites. And we solve for x. So I subtract 1 and get x is less than 2, and x is greater than, well, I subtract 1, so I get to negative 4. All right, which means when I put this on a number line, I would have open dots on both of these, but they would connect since we have an and situation. So get that absolute value alone and then deal with what's inside. So similar here, I'm going to split it up to x plus 1 is greater than 3, or x plus 1 is less than negative 3. And I solve, subtract 1 and get x is greater than 2, and x is less than negative 4. So we put it on a number line, and these ones in this case, since we have a greater than sign, we're going away from each other. All right, so we have our compound inequalities there. Now to just practice with a word problem here, a poll finds that candidate Garcia is favored by 46% of the voters surveyed, and Jackson is favored by 44%. The poll has an accuracy of plus or minus 3%. Okay, so it's going to be in that range of 3%, pretty close to what they get, but not quite exactly. So what we want to do is write and solve an absolute value inequality for Garcia to show the true percentage of voters for him. Okay, so Garcia is the one with 46%. So we can write an absolute value equation, and remember, we're going to say, okay, the true value minus, so the difference between the true value and the expected value, so my 46%, and I'll leave these as whole numbers as 46, needs to be within that 3%. So it needs to be less than or equal to 3%. And so I can solve that. I can say x is less than 46 is less than or equal to 3, and x minus 46 is greater than or equal to negative 3. Okay, remembering that that 3 is always going to be my difference amount. I add 46 to each side and get that x needs to be between 49 and between 43 to be the true value. It's going to be somewhere in that value. So if I were to put it as compound inequality, we would say his numbers are between 43 and 49. Similarly, for Jackson, we can write this and say the actual value of his voters minus what we have for the survey needs to be less than 3%, less than or equal to 3%. So we can solve that as well. All right, well, I have a couple more examples here that you can try for yourself, splitting those out and really making sure that you're using a less than for those and situations, greater than for the or situations. All right, get that absolute value alone and then deal with what's inside. All right, well, I hope this helps for your homework and for studying.